As Tomas and I discussed in our EARCOS presentation, we would be sending you some information on rich math tasks. There's really two ways to do this. You can either borrow rich tasks or build rich tasks. So when we talk about rich math tasks, we're talking about tasks that have a low floor and a high ceiling, meaning your kiddos who are um, developing their math at a slower rate or maybe came in a couple years behind or just not quite there with this certain topic, they have access to completing the task. And then high ceiling, meaning your high flyers who are maybe a year ahead, a couple years ahead, can still push their thinking within the task. It allows for productive struggle, meaning it's not an easily answered question, and there will be struggle whether you're coming in that low floor or high ceiling, that there's room to think hard and to have room for growth. It requires representation and justification. So mathematical thinking needs to be represented with models and math equations, and it needs justification. So when you see the models and equations, a student would need to justify their thinking and explain it. And of course, it builds a deeper mathematical understanding. As I mentioned in our presentation during EARCOS, rich math tasks have different solutions for the problem, different interpretations of the problem, and different strategies for solving the problem. Sometimes rich math tasks have all three, sometimes they have one or two of the three. The more of these elements you can incorporate into the task, the richer it is. All right, so for borrowing, you can use existing tasks. We've created a list of different websites that have ready-to-use tasks. This slideshow is also available just for you to click through on your own. And I will be sending that out in addition to this video. So you can look at it either as a video or as a slideshow. And if you look at it as a slideshow, you'll be able to click on these links. All right, so you can also build. This was a question at EARCOS. What do you do if you have Eureka or another math curriculum which you don't want to stray away from? You can use a traditional task and change it into a rich math task. So here are 5 different ways to transform traditional problems. You can use the notice and wonder strategy, the start with the answer strategy, the delete the question strategy, delete values, or give all the values strategy. As you probably know, this is not an exhaustive list. There are other strategies out there. These are just 5 strategies to get you started. So here's a traditional problem from Eureka's kindergarten curriculum. So it says Freddie has 3 strawberries for a snack. His dad gave him 2 more strawberries. How many strawberries did Freddie have now? And as you can see, it's very scaffold. It even shows exactly how to put it in. And then it says Freddie ate 2 of his strawberries. How many strawberries does Freddie have now? And just looking at this, you know it's not rich at all. It's really just a glorified, quick math fact that has some words above it. Like if a kid could ignore the words above it and still solve. So we know this is not a rich math task. Let's try to change it. Okay, so now we have a notice and wonder with multimedia. What you're going to do is pick a photograph or a video that's similar to your traditional problem. Then you're going to give time for kids to watch and look at the video or photograph and ask them to make noticings and wonderings. And when they notice, they might notice, the strawberries are red, the kid's picking the strawberries, things that are not necessarily math centered. But then they could also say there are 3 containers. They're all full of strawberries. And you're starting to move towards mathematical ideas. You're going to create this list, and at the end, you're going to have either 3 choices. One, you pick one wondering for everyone to work on, or you could pick a couple, maybe the top 3. One that's easier to access, maybe that low floor, or in a higher one, high ceiling. So a couple of wonderings for kids to select from, or you can have it be a completely open-ended wondering, solve for whatever you feel strongly about, and I'll come around and support you. Here's another example. This one's called Start with the Answer. So in the morning, Freddie's dad packed him some strawberries for snack. At snack time, Freddie ate some of these strawberries. And after snack time, Freddie had 3 strawberries left. 3 strawberries left is the answer from that traditional question. So if you start with that answer and then ask a kid to work backwards of what are the possibilities, it's open-ended and has endless solutions. So it says, how many strawberries could Freddie's dad have packed him for snack? And how many strawberries could Freddie have eaten during snack? And hopefully the kiddos, as they create this solutions for this problem, will notice that they're always going to have the same difference between these two numbers, right? So if Freddie's dad packed him, let's see, packed him 10, right? Then he should have eaten 7. And the difference is 3, right? The difference between 10 and 7 is 3. If he packed 11, then he would have eaten 8, and the difference is still 3. And hopefully they would start picking up the pattern within that. All right, you could delete the answer. So Freddie had 3 strawberries. His dad gave him 2 more strawberries. Then Freddie ate 2 strawberries. So you can ask kiddos, like, what do you want to know from this? What kind of questions should we ask? And just developing that question itself is very rich. But then the representation between of this idea will be very different than the traditional problem. The traditional problem explicitly wrote out the math equation. You might have kids drawing pictures. You might have kids using number lines. The representation of this actual mathematical process would be very different than the traditional problem. You can also delete the values. So Freddie had some strawberries. His dad gave him some more. Then Freddie ate some strawberries. Freddie has some strawberries left. So basically, you can replace any value with the word sum and then have kiddos pop in values depending on their level. They could be easier values to harder values, and it gives differentiation within this problem. You can also just give all the values. So it's strawberry season. Everybody has strawberries. Some people are eating strawberries and some people are giving away strawberries. And then here's a list of who has strawberries, who's eating strawberries, who's giving away strawberries. And it's a bit overwhelming. And sometimes that's how it is as mathematicians, is we're just given a lot of data and we have to make sense of what matters and what kind of connections we're seeing. So over on the right hand side of this slideshow, you'll see you can brainstorm questions with kids, like who has more strawberries, how many more strawberries do they have, how many could mom have, right? How many could she have before she eats her snack or her set of strawberries? How many after she eats her snack? So having kids develop this strong sense of values changing over time and value comparisons and really just asking questions that they're interested in. All right, rich math test summaries. You can build them, you can steal them. It really doesn't matter. Struggle is really good. Kids need to struggle through these. That's how they're going to grow their mathematical understanding. Torture is not okay. So if kids are struggling so much, they're shutting down mentally. They're not engaging in the task. It's no longer a rich math task because it means that that the floor is not low enough. You can have kids work independently, but you can also have them work collaboratively, either in pairs or in small groups. It depends on what you would like out of your math time. And students must share their thinking and their work because a lot of the growth students are going to experience during these math workshops is when they share with others and learn from others. So kids will approach in different ways with different levels of efficiency. And what you want students to do is to start slowly stealing or borrowing ideas from other students, noticing that this kid is doing it more efficiently and I too can do it more efficiently if I copy his strategies. So you want kids to naturally start picking up these strategies. All right, the brains. This section is really just about highlighting some of those, I want to say like the godfathers of math education. It's probably not the best way to put it, but some of these people have those thoughts that are really pushing mathematics forward recently. And I want to highlight Dan Myers, Annie Feder, and Joe Bowler. And they also have videos that explain some of these rich math tasks worth of view. Some of them are a little longer than others, but if you have time, I definitely recommend watching them. So Dan Meyer is about the 3-act math, and he uses multimedia and encourages student intuition. And he reminds teachers to please keep questions short and let students build the problem. So some of those rich math tasks we talked about earlier talked about letting students understand and build a problem themselves, ask those questions on their own.